Good afternoon, folks. I'm back. I'm Joe Weiss. I'm a gastroenterologist physician. Gave the earlier program, and I wish I had more time for that one, but there is limited time for this one, so we're going to go right into it. This one is called The Quest for Immortality and Vitality. And what I'd like to share with you, and the odds are very, very high, that you will be living a lot longer than you think, particularly if you're young and healthy. Lifespan will continue to grow, and it has been growing for the last 100 or so years. A lot of that is due to reduced infant mortality. That is, people still live to about 70, 80, 90, 100, up to 120, and that was considered the extent. But the science of longevity and the potential of immortality is advancing very, very quickly. So let me just share with you, there are other disciplines which have advanced very quickly. Top two slides. From the first airplane flight at Kitty Hawk to supersonic transport took less than 70 years. That's pretty amazing progress. The lower one, the first solid fuel rocket to landing on the moon and returning a man to Earth, again, about 50 years or so. Pretty amazing progress. Taking a look at the microbiome and genomics, the advances are staggering, even faster than these experiences with the astro-aeronautical theme. Speaking of astro-aeronautical theme, I feel sorry for the birds who are saying that they're getting freaked out by the wireless technology. Now, I do want to share with you that lifespan is variable, and there are species on this planet, and if we just go with the rodents alone, the range of lifespan is pretty dramatic, from just a few months to many, many years. The bottom right is the naked mole rat. I thought you'd want a closer view of that one. This is what he looks like. This is an X-rated program, is that what this is? The naked mole rat is actually an amazing animal. It lives about 28 to 30 years, does not get cancer, and is being used in longevity research. So it's a very attractive life form to deal with. But I do want to share with you that when you start as a single cell, and we all started as a single cell, you've heard the term exponential a couple times this morning, exponential growth. I want to make sure you really understand what exponential growth means. We start off as a single fertilized cell. The cell divides in two. Those cells divide in two. Those cells divide in two. If I were to offer you $1 million cash right now, how many people would take it? You don't want $1 million cash? Okay. How many would rather have one penny and have that penny double each day for a month? Okay, those who really know will go for the penny because they know the power of exponential growth. That one penny, if you double it after the first week, it's about $1.27. After the second week, it's about $10. After the third week, it's about $200. After the fourth week, it's $1 million. And after 30 days, you have $10 million. That is the power of exponential growth. So we start off as a single cell. The cell divides, multiplies. If it continued indefinitely, by the time the 9 months of pregnancy were over, the poor mom would be carrying around an elephant weighing several tons. So the cell division has to stop, but it continues in cancer cells and it continues in stem cells. So you can move very, very quickly, but you can also age. So you start off as a single cell. As an adult, you're talking about 37.2 trillion cells is the latest estimate of how many cells an adult human has. So you've gone from a single cell to trillions. And then we age. And again, lifespan, longevity, has gone up in a fairly linear phase over the years. But something striking is happening. Something striking is happening, and this is just going back. Remember the blue zones? That was the state of longevity research a number of years ago. You look for areas where people lived long and see what they did in common. So Loma Linda University area, a lot of Seventh-day Adventists. Vegetarianism is found to be associated with longevity. Those who are in Okinawa, Japan, have turmeric, which is curcumin, which basically has a COX-1 inhibition. It's an anti-inflammatory. That's helpful. Sardinia, the Mediterranean diet, the polyphenol wines, the fava beans. A lot of these things are common sense, and we recognize, okay, these are associated with longevity. We're probably well off to imitate and try to follow a lot of these, which does make sense. But also realize that there is a danger to living on planet Earth, and a lot of it has to do with external environmental concerns, and this leads to damage to the mitochondria, it leads to damage of the DNA, and a number of it has to do with tobacco, ultraviolet light radiation, solar radiation, pollution, inflammation. Inflammation is a very big one that all play a role in the aging process. Inflammation is associated with a whole host of disorders, and some you've heard about this morning already. But I do want to share with you that inflammation appears to be one of the main keys in aging. So if you could reduce inflammation, you may be able to slow down the aging process. There's another factor involved. You heard the term epigenetics. Epigenetics is a fancy way of saying something outside of the gene. Now, we all have genes. Humans have about 23,000 genes. As I mentioned to you in the earlier program, genes are critically important. They describe the design of proteins, and the proteins have functions from neurotransmitters to hormones to every single enzymatic function a cell has, all of cellular metabolism, all directed by genes. The genes are present in humans, 23,000. They're present in every single life form. We share a lot of these genes with all sorts of other animals and plants and microbes. Epigenetics is something important. It basically says that genes by themselves are not your destiny. You may have genes, you may have inherited genes, but epigenetics can turn the genes on and off. It can modify the genes. So epigenetics can be environmental. It could be temperature, radiation, food, drugs, nutrients, probiotics, microbiome, you name it, it can affect the epigenetics. I think the best example of epigenetic phenomenon is a caterpillar. A caterpillar is identical to a butterfly in the DNA, in the genes. It's the same organism, but it's the epigenetic changes that change it from a caterpillar larva to a butterfly with wings flying. And that is the same genomics, the exact same genes. That's just epigenetics at work. And epigenetics are at work everywhere. Your genes are not your destiny. Epigenetics plays a major role. And going back to the microbiome plays a major role in epigenetics. We were talking earlier, I wish there were time for more questions about the diet and the importance of the diet. The diet changes the microbiome. The diet also contains chemicals, metabolites, genes, products, hallucinogens, stimulants, you name it, they're present in the food. So we're talking about a couple of products that might induce hallucinogenic phenomenon that can become habit-forming and addicting. Every product that you consume in your diet has some form of biological activity. And again, a lot of the genes are shared, so your diet is much more important in your health and wellness than you might think. In fact, it goes back about 2,000 years ago. If you follow what Hippocrates said 2,000 years ago, his words of wisdom are true today as well. He said, let your foods be your medicine, and your medicine should be your foods, because food actually is medicine, and it does impact not only the microbiome, but the brain directly, your whole body, your whole physiology directly. You heard about telomeres earlier. That's just one aspect where we recognize that it's a marker for longevity, and the shorter the telomeres become, the shorter the lifespan of the cell. You can think of the telomeres as the caplet of a shoelace. Without that caplet, without the telomeres, the chromosomes can disintegrate, fall apart, the cell will no longer live. With the preservation of the telomeres, you can preserve the shoelace, you can preserve, hopefully, your lifespan longer. Genetics is fascinating and sometimes frightening. There is an illness called progeria, you may have heard of. It is a terrible disease for those who have it, but it may also be beneficial for those who do not, because it is pioneering in terms of understanding the role of genes in aging. Progeria, the victims of progeria, age rapidly. They age dramatically. Someone has speeded up their biological clock. So by the time they're 10, they're the equivalent of being in their 80s or 90s. By the time they're 12 or 15, they're usually no longer with us. It's a terrible disease, but again, it's uncovering a lot of the mystery of the genetic influence on aging. There's other condition, which is the exact opposite, where people have a genetic disorder where they do not age, or their aging is very, very slow. Found in South America. It's a remarkable small population, but they can be in their 30s and they look like they're 10 years old. Biologically, they look like they're 10 years old. And as I mentioned earlier, there was a roundworm Caenorhabditis elegans that Sidney Brenner worked on at the Salk Institute. That one gene, manipulation of one single gene, can influence lifespan tenfold. So the importance of genomics, genetics, epigenetics in longevity is just beginning to be uncovered. Now, I like the headline which suggests that the medical advances are advancing for the mice, not necessarily for humans. Mice are used in genetic research and biological research. There is a tremendous overlap. It's about 92% of the genes are identical between a mouse and a human. So they are a model. And a lot of the scientific data developed in mice is extrapolated to humans. So it's fascinating research work. By the way, I also want to share there are so many approaches to longevity that even if only one of them panned out, you can expect significant enhancement to lifespan over the years and decades to come. So you have epigenetics, you have the microbiome, you have stem cells. Stem cell transplants have been around for about 50 years. You may not recognize it, but bone marrow transplants are basically stem cell transplants. They've been around for 50 years. Stem cell transplantation does work, and it's working in more areas than most people are aware of. Stem cells can regenerate any cell in the body. It's the original cell. It's much like the first cell of your body when the egg was fertilized, becomes every cell of your body 100 trillion cells later. A stem cell can be directed, and the science has advanced to where they can direct the stem cell to become very specific tissue, and using scaffolding of an inert material, you can grow biological organs. Strange as it may sound, they have already been grown and transplanted successfully. Stem cell artificial trachea have been transplanted. Not to become too sexist about it, but artificial sexual organs for women have been transplanted. They're working on transplanting hearts and other organs as well, generated from stem cells. The science is advancing rapidly. Remember, there was a great controversy because a lot of the stem cells were derived from fertilized embryos that were to be aborted. So there was a great hue and cry about it would help to promote abortions. That's not what happened. And the good news for the science is that it's gone well beyond the fertilized embryos that are required. You can actually take mature adult cells, regress them back to stem cells, redirect them to a completely different tissue. So the technology is evolving very rapidly, and the science is exciting. Well, besides stem cells, what about bioengineering? What about artificial organs, artificial limbs, artificial eyes, artificial hearts? You know, so many people die of a heart attack or cardiac failure. Well, you can grow a new heart with stem cells. That sounds attractive, but what if you happen to have a battery-operated replacement heart, perhaps one that was nuclear powered, that will keep you going for another couple of hundred years? That technology is coming along very, very rapidly. So much so that technology is actually superseding the human physical capabilities to where it actually has reached Olympic sport level. Do you know those running blades that are available for people who have prosthetic limbs? They're illegal in the Olympics because the people with the running blades can run faster than people with natural feet. So again, we're talking about technology and biotechnology advancing so rapidly. Another concept, again, will be playing a role in longevity, is called nanotechnology. Nano is extremely small. Nanotechnology, do you guys remember a movie from must be about 60 years ago or 50 years ago, Fantastic Voyage? This is the same idea. I don't know if they've remade that movie, but it's coming. Fantastic Voyage is coming to our real lives very soon, where you're going to have technology that can travel through the body, through the bloodstream, to various tissue, and manipulate and modify it. It's also going to come about with using viral transfer of genes. You're going to have gene transfers, genomic transfers. Now, you may think it's all science fiction. Let me throw this one at you. Did you know that there is a gene in the firefly that causes illumination? causes the firefly tail to glow in the dark. The fellow who did this work, Arjun Chen, got the Nobel Prize for his work on the luminescent gene. They're actually able to transplant it into other organs, other tissue, and they actually transplanted it into a cat. There is a cat that glows green in the dark. So this is a gene that's been transferred. They actually have transferred it to tobacco plants. You can see the plants growing in the dark. Science fiction or horror, it's kind of hard to decide which way, but because of the great overlap in genes and the ability of genes being the universal language, to go from one organism to another is opening up either a new horizon or a Pandora's box, depending on how you want to look at it. Another way to enhance longevity, you probably heard about it, wasn't displayed today at lunch, was caloric restriction. And if you had the dinner plate on the right served to you, you may think you're living much longer, or it may just be that the years are being stretched out because you're suffering from all the caloric restriction. But they're finding now that there are ways to basically reproduce caloric restriction in pill form. You're able to use a metabolite to give you the same biological benefit of slower aging by taking it in a form like that. Antioxidant foods are becoming more popular. Again, oxidation, inflammation, metabolism. I like this cartoon. What fits your busy schedule better? Exercising 1 hour a day or being dead 24 hours a day? Now, you've heard a lot about exercise today, and exercise is important. And if you were to pick and choose one part of this talk, the most important part, exercise, is also associated with longevity. So by all means, do it. Again, fantastic voyage in my field, gastroenterology. I do want to save lives today. I want to warn those who are not aware, if you're age 50 or over, you should get screened for colon cancer. Tragically, it is a devastating disease, but it is identifiable early, curable early, particularly if there's any family history of inflammatory bowel disease or colorectal cancer or colon polyps. And one of the new diagnostic approaches is not the garden hose colonoscopy, is swallowing a small capsule. The image is much enlarged. It's the size of a horse pill. You swallow it, it takes pictures all the way through your digestive tract. Interesting home movies, but it's another alternative. There's also a new FDA-approved using genomics DNA test. Is you provide a wonderful fecal sample. You don't tell the mailman what you're putting in the mail. You mail it off, and they analyze for markers for genes for colon cancer and colon polyps. Oops, let me skip over that. Another approach to longevity is freezing, cryopreservation. You probably have heard all about the Ted Williams fiasco, whether his brain is frozen in Arizona and it'll be resuscitated in the future or not. Strange as it may sound, there is a rationale to the science behind cryopreservation. I do not advocate it. I don't believe it's going to be a very useful methodology. What happens when you get thawed out? Is the technology going to be there? Or if you do wake up in a couple hundred years, what are you going to be thinking about? But there is a rationale for it. But I do want to share with you one important approach to longevity. I want to make sure that you enhance your lifespans now, is the advance of personalized medicine. Medicine is population-based. That is, you are treated with one pill that works for a lot of people, but it's not one size fits all. It's basically personalized and should be personalized. So when you're looking at your own therapy using genomics, you will find that the years to come, personalized medicine will be much more designer-driven. Now, and again, drugs do have side effects. Every once in a while, it'd be nice to have a side effect which are attractive. I do want to share just 2 slides, tips for a long, healthy life. Basically, this is going back to ancient philosophy time. There are no brilliant words of wisdom here, just all common sense. But one other common sense thing I would like to leave you with, as I'll show you the second slide, is the world is more dangerous than you might think. And if I may have the bully pulpit for about 60 seconds to share with you and hopefully protect your lives, you need an advocate protecting you if you get hospitalized. If you're in a hospital, you need someone watching over you, protecting you. As much as I'm proud of medicine, it has a terrible track record in hospitals. Do you know what the death rate is in the United States in hospital accidental deaths each year? 440,000 deaths each year in American hospitals by accidents, by medical errors. A lot of it is drug reaction, drug interaction, and we're talking earlier about the microbiome, and I suggested be careful about probiotics because you don't really know what they're going to do. There are millions of them out there, and each microbe produces thousands of proteins, each one of which has a biological effect. We don't know what they're going to do. We do know the drugs are out there and they interact and they cause side effects, but there is no central database. Nobody is collecting the data. Nobody is putting together a computer software program to identify which drugs are killing people in which combinations. So Deepak Chopra, myself, Nancy, and others have started an op-ed piece, and we're trying to promote the idea of being an advocate for your own wellness, encouraging the government to be more promoting preventive medicine, integrative medicine, public health, safety first. Be careful out there. Have a long, wonderful life, but just because you have a long, wonderful life and a lifespan that may go out to 1,000 years doesn't mean you're not going to be killed off by your well-meaning doctor when you're hospitalized for pneumonia.
I wouldn't stop you, but we got to ask you Thank you so much, Joe. I mean, great speaker, Joe. We're glad we had you give a couple of talks. That's fantastic information.